my YouTube channel. This afternoon, we want to look into indices. I'm Nwachukwu Daniel. Please, don't forget to subscribe to my YouTube channel. Please, I'm begging. I'll appreciate so much. So, this afternoon, we want to see what indices is all about. Indices is a plural form of the word index. In English dictionary, an index simply means power. So, index of a number simply means power of a number. What do you mean? 3 raised to the power of 4. Index of 3 means the power of 3. That is 4. This is your index or power. Whereas this is the base. What does 3 raised to the power of 4 mean? What does index or power tells us? It tells us how many times we have to multiply the given base. So 3 raised to the power of 4 simply means we should say 3 times 3 times 3 times 3 into 4. That will be giving us 81. Okay? Now, we have to know how to solve a given indices equation. We have to know how to reduce a particular question to its basic index form. Take for instance, if you are giving 81 and they say put it in an index form, the implication is think of a number. You can multiply, you get to 81. Try these numbers: 2, 3, 5, 6, 7, 9, 7, 10, 11, etc. So try these numbers. These numbers are the numbers you can use to see if you can reduce that particular number to its basic index form. Now I try 2. 2 times 2, 4, times 2, 8, times 2, 16, times 2, 32, times 2, 64, times 2, 128. 128 is more than 81. It means I cannot get 81 from 2. That is 2 times 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 2, 4, times 2, 8, times 2, 16, times 2, 32, times 2, 64, times 2, 128. 128 is already greater than 81. And I noticed that when I was multiplying this, I did not get 81. It means that I cannot get it from 81, I'll clean it. Then I try 3. 3 times 3, 9 times 3, 27 times 3, 81. Hey, I can get it from 3. Okay? I ask myself, I got it from 3, right? How many times did I multiply it? That is what the index or power will answer. How many times did I multiply it? 4 times. I said 3 raised to the power of 4. So 3 raised to the power of 4 is the basic index form of 81. If you make a mistake and you say 9 raised to the power of 2 is the basic index form of 81. You know that 9 raised to the power of 2 is 81. But that is not the basic index form of 81. And you writing 9 raised to the power of 2 as the index form of basic index form of 81, you are very wrong. So this is the basic index because we did not put 9 here. Only 2, 3, 5, 6, 7, 10, 11, and so on. Okay? So 3 raised to the power of 4 because you can still reduce 9. Because you can still reduce 9, 9 will be 3 times 3. So it will be 3 raised to the power of 2, which is 9 times 2. That is 3 raised to the power of 4. Giving you the basic index form of that number. So that is how you try any number given to you. Any number given, let's say they gave me 128. They say I should put it to basic index form. I try 2. Start with 2. 2 times 2, 4, times 2, 8, times 2, 16, times 2, 32, times 2, 64, times 2, 128. I will say 2 times 2 times 2 times 2 times 2 times 2. 2 times 2, 4 times 2, 8 times 2, 16 times 2, 32 times 2, 64 times 2, 128. 1, 2, 3, 4, 5, 6, 7. I got it from 2, right? How many times did I multiply that 2? That is what index of power will answer. How many times? 1, 2, 3, 4, 5, 6, 7. 2 raised to the power of 7. I'll say this is the basic index form or the simplest index form of this 128. There are so many ways power of a number can appear, and as so we have lots of indices. Because there are so many ways powers of a number can appear, we have lots of indices. And one of it is what we call multiplication law. Multiplication law, which says that when you have two numbers of the same base, two numbers of the same base and with powers, let's say we have it this way. Two numbers of the same base with their powers. That is 3 raised to the power of 2 times 3 raised to the power of minus 3. This is multiplication. They must be of the same base. So if you have it this way, times 2 raised to the power of 3. Don't apply multiplication law. Why? Because the two bases are not the same. They are different. Only when the two bases are the same that you apply multiplication law. Then, how do you apply it? Take their common base, 3. Add their power. Plus times minus is minus. So 2 minus 3 will give you minus 1. So we add the power by saying 2 plus minus 3. That will be giving us 3 raised to the power of minus 1. Now, 3 raised to the power of minus 1, another rule of indices will still answer this question. We'll keep the answer pending. Another rule of indices will answer it. But let's proceed first. Number 2, division law. Division law says that when two numbers of the same base are added together, let's say 5 raised to the power of 3 divided by 5 raised to the power of 1, for instance. As far as the bases are the same and you see division law of indices will come in. Take their common base, 5. Now, because there is division here, you put minus. So 3 minus 1, that is 2. It will be giving you 5 raised to the power of 2, which is equal to 25. Right? Good. Then, another one says zero index law or zero power law. This law states that anything raised to the power of 0 is 1. That is, 2 raised to the power of 0 is 1. X plus y raised to the power of 0 is 1. Chidons raised to the power of 0 is 1. That is what it means. Anything raised to the power of 0 is 1. Then we have another one that says negative power law. Negative power law or negative index law. This law says that if any number has negative power, remember here we have negative power. It says that this minus you have at the power will be replaced with 1 over. Then write every other thing, 2 raised to the power of 3. Replace the minus with 1 over, then write 2 raised to the power of 3. So here now, to finish up this question, we say that means 1 over 3. So 1 over 2 raised to the power of this, 2 times 2 times 2 will be giving us 1 over 8. Then we have the next law, fractional index law. Fractional index law. This law says that when you have a number, let's say 5, and let's say 25 for instance, and it's raised to the power of 2 over, and it's raised to the power of 3 over 2 for instance. Now, the implication is that what you do is that There are two ways you can sort out this. First way is, you say that this means take the denominator, which is 2. The denominator of the power, which is 2. Put it inside the square root sign. Then put 25. Then say all raised to the power of the numerator 3. I said the first way is take the denominator of the fraction, put it inside the square root sign, then put 25, then say all raised to the power of the numerator 3. This thing you just put, this thing, this square root of 25 simply means, what number will I multiply 2 times to give me 25? 2 times 2 will give me 4, not 25. 3 times 3 will give me 4, not 25. 3 times 3 will give me 9, not 25. Then 5 times 5 will give me 25. It means 5 is the number I will multiply 2 times to give me 25. I will write 5. 5 raised to the power of 3. That will be giving me 125. Then another method I can use is reduce 5 to its basic index form. I will be having 5 raised to the power of 2. Then I'll say raised to the power of 3 over 2. 25 to its basic index form is 5 raised to the power of 2. Then I'll say raised to the power of 3 over 2. This we cancel this. That will be leaving you with 5 raised to the power of 3 equal to 125. Now, that is about fractional index law. We go to the next one, that is negative fractional index law. Negative fractional index law. This law says that when you have, next one is negative fractional index law or negative fractional power law. This law says that when you have, let's say, 81 raised to the power of 3 over 4, and that power is minus, negative fractional index law. This minus will be replaced with 1 over first. Consider the minus first by replacing it with 1 over. Then you write 81 raised to the power of 3 over 4, which you can sort out in any possible means you want. I can sort it out by saying 1 over. Reduce 81 to its basic index form. I will have 3 raised to the power of 4 bracket 3 over 4. This will cancel this. That will be giving me 1 over 3 raised to the power of 3 equals to 1 over 27. Answer. As far as I've succeeded in converting that number to its basic index form, it has made things easy for me to solve. Then the next law is product power law. Product power law. This law states that when you have, let's say, 2 raised to the power of, when you have a raised to the power of 2 raised to the power of 3, a raised to the power of 2, b raised to the power of 3, all raised to the power of 2. It means that this power 2 will go inside and multiply every of the thing you see inside. So 2 times 3 will give me 2 raised to the power of 6. 2 times this, 2 times 2 will give me a raised to the power of 4. 2 times it will give me b raised to the power of 6. Okay? And 2 raised to the power of 6 means 2 times 2 times 2 times 2 times 2 times 2. 1, 2, 3, 4, 5, 6. 2 times 2, 4. 4 times 2, 8. 8 times 6, 6 times 2, 32, 32 times 6 is 4. You write 64, a raised to the power of 4, b raised to the power of 6. That is the final answer. Product power law. Now, product based law. Okay, so this law is called product power law. Then, this law can also be called product based law. Why do we say we can also call it product based law? You see the bases are, we have up to 3 bases. 1, 2, 3. multiply it together, and one index or power is what they have. So they can be called product power law or product base law. Then this product power law can be put like this. This product base law can also be put like this. A raised to the power of 3, A raised to the power of 3, 1 over 3, B raised to the power of 1 over 3. Then the implication is that this will go into this and this. This is still product based law. Then this will go into here to be giving you A raised to the power 1 over 3 times 3 over 1. B raised to the power 1 over 3 times 3 over 1. This will cancel this. That will be giving you AB. Then you can also see this product power law this way. You see A raised to the power of 2, 1 over 3. That is a single number with a power, multiply with another power. This implication is this times this, it will be giving you A raised to the power of 2 over 3. So these are examples of product power law, which combines with this product based law. So the product power law was sorted out along with the product based law. Then another law we want to check is fractional base law. Fractional base law. Look at what the fractional base law states. A over B raised to the power of 2, 3, or raised to the power of 4. It means that this power will go into every of this number in the fraction. 4 raised to the power 4 times 2 will give me A raised to the power of 8. 4 times 3 will give me B raised to the power of 12. So this is fractional base or quotient based law. This is called fractional base or quotient based law. So that is it. These are the laws of indices we have. Now I want to simplify the question we have. We want to solve the question they gave to us. Now, they say we should sort out this. This is under product based law. So we say change this to its basic index form. It will give you 5 raised to the power of 3. 5 times 5 times 5 will give you 125. A raised to the power of 3, B raised to the power of 3, or raised to the power of 1 over 3. That means 5 raised to the power of 3 times 1 over 3. A raised to the power of 3 times 1 over 3. B raised to the power of 3 times 1 over 3. Pia, pia. So that will be giving us 5AB. That is your answer. They say we should solve 0.064 raised to the power of minus 2 over 3. First of all, take care of this minus. To take care of this minus, you say this will mean 1 over 0.064 raised to the power of 2 over 3. We have taken care of this power of minus. Then, change this to fraction. This decimal point will carry 1. Every other thing will be 0. So that will be giving us 1 over, this will be giving us 1 over 64 all over 1000 to power of 2 over 3. Now, change 64 to basic index form. Change 64 to basic index form. That will be giving us 2 raised to the power of 2 times 2, 4 times 2, 8 times 2, 16 times 2 times 2 times 2 raised to the power of 6. All over change 1000 to basic index form. It will give you 10 raised to the power of 3. So this power will go into each and every of it. So times 2 over 3 times 2 over 3. So, as the power goes into every of it, this will cancel this to give you 2. This will cancel this. So, the answer will be 1 over 2. 2 times 2, 4. All over 10 raised to the power of 2. Now, this means inverse of this fraction. Inverse of this fraction means if you have 1 inverse of 22 raised to the power of 4 and 10 raised to the power of 2, it will be giving you 10 raised to the power of 2 all over 2 raised to the power of 4. 10 raised to the power of 2 will be giving us, 10 raised to the power of 2 will be giving us 100. All over 2 raised to the power of 4 will be giving us 16. Final answer. Reduce to lowest term. You will be having 4 here, 25. 4 here, 4. That is 25 over 4. Okay? Then, we go to the next question. The next question says 256 raised to the power of 256 raised to the power of 3 over 8. Change 256 to basic index form, you get it from 2. 2 raised to the power of 8 will give you 256. 2 times 2, 4 times 2, 8 times 2, 16 times 2 times 2, 64 times 2, 128 times 2, 256. So 2 raised to the power of 8. Then say all raised to the power of 3 over 8. This will cancel this, giving you 2 raised to the power of 3. Which is 2 times 2 times 2 will be giving you 8. So it means that the answer to this one is 8. The answer to this one is 25 over 4. And the answer to this one is 5AB. Then we go to the last question. This last question says simplify this. Now, knowledge of indices will tell us that we apply product law here. It will be 15 raised to the power of 2s times 15 raised to the power of 1. Okay? Times 25 raised to the power of n. This one, 9 raised to the power of 2n simply means 9 raised to the power of 2 bracket n. 9 raised to the power of 2 will give you 81 raised to the power of n. So, we now say 9 raised to the power of 2n will be giving us 81 raised to the power of n. We now say all over 75 raised to the power of n times 3 raised to the power of n plus 1. 3 raised to the power of n plus 1. Returning back to indices, it will be 3 raised to the power of n times 3 raised to the power of 1. n plus 1. Okay? We'll be having 3 raised to the power of n times 3 raised to the power of 1. Then this one will be 45 raised to the power of 2n. Simply means 45 squared all raised to the power of n. They are the same. So, 45 times 45 will be giving us 205. 2025, please. So, 45 squared will be giving us 2025. Then raised to the power of n. Then, once we have this, 25 raised to the power of n times 81 raised to the power of n. Once the powers are the same, multiply their base. You say 25 times 81 all raised to the power of n. So once their powers are the same, multiply the base and raise to one of the powers. So that will be giving us 225. 2025 raised to the power of n all over 2025 raised to the power of n. Then 15 times. So we have multiplied this and this to give us 2025 raised to the power of n. We multiply 45 squared. It gave us 2025 raised to the power of n. Then times 3 times. Now this one, 15 squared, will give you 225. Now these two have same power. 75 raised to the power of n times 3 raised to the power of n. That will be giving you 75 times 3 all raised to the power of n. That will be giving you 225 raised to the power of n. So we have 225 raised to the power of n, 225 raised to the power of n. 15 squared, 225, then power of n. 75 times 3, 225 raised to the power of n. This will cancel this. This will cancel this. 3 here, 1, 3 into 15, 5. Therefore, this answer will be giving you 5. So once you simplify it, it will be giving you 5. See the application of these indices.